Today, we're going to be discussing the chain rule. To the upper hand side of the screen, you can see the formula for the chain rule as such. And while the chain rule, when first exposed, can get quite confusing, it is one of the most essential derivative rules in calculus. Without the chain rule, you basically cannot differentiate many functions and problems on tests and on questions. So what is the chain rule specifically? Because it might not get to you intuitively when you just look at one simple formula. And first, to understand the chain rule, you must first understand the power rule. These two rules are the most often confused rules in calculus when you first learn it. Because often in curriculums, you learn the power rule first and then the chain rule because the power rule is much simpler. And the power rule is also much more famous. What is the power rule? Well, any polynomial, notice polynomial, x represents a polynomial or any variable differentiated in respects to x will be the same thing as n times x to the n minus 1. You can think of it as you move the power to the coefficient of x and you subtract the coefficient by 1 to get its derivative. And as always, to understand derivatives, derivative is just the instantaneous rate of change, or in other words, the tangent slope to that point or to any point on the function, which is the formula and the resultant for the power rule. That is the same thing for the chain rule, except a little differently. Because when we are exposed to the power rule, such as 3x squared plus 5x plus 3 differentiated, that will give us a differentiated function, but that function only has to deal with this polynomial. It's not a composite function. So differentiating this gets 6x plus 5. The more you do, the more practice you get on doing derivatives, the more fluent you'll be at it. And this resultant function will give us any tangent line's slope for any input of x. But notice how this is just a regular polynomial. Or we can say such as x to the third power. This is also a polynomial, except this is a monomial, which differentiated will be equal to 3x squared. But the point is that none of them are composite functions. And what is a composite function? A composite function is a function within a function, such as f of g of x. G of x is a separate function, but f of x is also a function, whereas g of x is the input of x in respects to f of x. That is all a composite function is. And when we were dealing with composite functions, it comes especially useful to use the chain rule. So let us try to differentiate sine of cosine of x. Cosine of x in itself is a function, same as sine of x. So when we take the derivative in respect to x of this function, we must use the chain rule. And the chain rule states that we take the derivative of the outside function first, so this is f of x, and then we take the derivative of the inside function, g of x. So you can think of it as enclosed boxes. You take out the outer layer, then take out the inner layer, and it goes all the way down until the x function. So the derivative of this will be equal to, well, what is sine x's derivative? And the reason why we need to do this is because remember, sine of x is a function in itself, so we must take the derivative of that function first, which is cosine x. Cosine of cosine x. And now we must take the derivative of the inner function, cosine of x, which the derivative of the cosine function will be negative sine x. These are two derivative rules you must understand and memorize. So you multiply this by negative sine of x. And then when people think that we get to this stage, we're done. But are we really done? It might look like we're done, and yes, the answer is this, but to get a truly deep understanding, we must also take the derivative of x, because x in itself is also a function. Y is equal to x is a function, isn't it? Therefore, we must differentiate x as well. But the differentiating x will result in 1. Therefore, we just leave it out. But it is important to understand it goes all the way down until the very last function. And that is the chain rule in a brief contextual understanding. And in future videos, we'll be diving into more specific questions which deal with much more rigorous differentiations, such as much more bigger and much more complex composite functions.